Question 19. The diagram shows a circle inside a semicircle. The circle has a diameter of 10 centimeters. The semicircle has a diameter of 20 centimeters. Work out the shaded area. So I need to work out this area. So I think probably the best way for me to go about it is actually to kind of just see this part here. And just work with that part. Just work with that part there, if you see what I mean. Because this part here, none of that's shaded. So I can work out this shaded area here. Now, this shaded area here would be a quarter of the larger circle. Okay, that's a quarter of larger circle. And I'm going to take away this half of the smaller circle. Right? If I take away that half of smaller circle, then I will get that shaded area. So this is to do with area of circles. So straight away, I'm just going to write the area of a circle, because I've remembered this from my formulae, is equal to pi r squared. So this is the key thing which I'm going to need for this equation, for this question, and I'm going to work out what the area is of a quarter circle and subtract half of the quarter of the larger circle, subtract half of the smaller circle, and I will get that shaded area. So, first thing is that they're trying to trip you up by giving this information here as diameters. But you need the radius for this formula. So, my larger circle here has a radius of 5 centimeters. Oh, sorry, that's the larger circle, a radius of 10 centimeters. And my smaller circle has a radius of 5 centimeters because it's half of each of the diameters. So, let's work with this quarter of the larger circle. So it's going to be pi, the radius here is 10, so pi times by 10 squared, and then I'm going to divide it by 4, because I've got a quarter of the area, right? It's only a quarter of the circle, so I can divide that by 4. So therefore, I've got, so 10, you could just enter that on your calculator. But I'm going to enter this as 100 pi, because I know 10 squared is 100, divided by 4, which is the same as 25 lots of pi. Okay, that's my area for the big circle. Now, the reason exam questions may require you to keep it in exact form, so I'm going to just leave that in exact form for now. Also, you don't want to round early, or you might make a mistake. Okay, so it's kind of better to work with these exact values, if you can. So that's my area of the quarter of the larger circle. Then I've got this area of half of the smaller circle. Well, that's going to be pi times by 5 squared divided by 2. Right? Because 5 is my radius of the smaller circle. So pi r squared, but because it's half of a circle, I'm going to divide it by 2. This is the symbol for therefore. So therefore, I've got 25 lots of pi, because 5 squared is 25, times by pi, and then divide by 2, which is 12.5 pi. Now, so if I take my bigger circle and I subtract my smaller circle, if I take the quarter of the larger circle and subtract this half of the smaller circle, then I have 25 pi, take away 12.5 pi, which is 12.5 pi. And that's going to be my answer. Now, you could have worked these out, you know, and then put the whole thing into your calculator, but I think this is a better way of doing it. Usually it will avoid errors doing it that way. So calculator, 12.5 times by pi equals 39.269, etc. centimeters squared area. But then I need to last mark, I need to then give the answer correct to 1 decimal place. So that's then going to be 39.3 centimeters squared, because it rounds up to the next decimal place. Now here's a little exam trick for you guys. If you, let's say, had no idea about it, you'd forgotten the area of a circle, well, shame on you to start with. But if you have, leaving aside the shame on you bit, you could write any number here. You could write 106.81 and then round it here to 106.81, round it here to 106.8, you would get 1 mark. Yeah, if you did nothing else in that question, because they want to give you 1 mark for a correct rounding. So that's just that piece of information.